So lesson 5, which is the last lesson of our log and exponents units, has to do with log scales and applications. Now, according to the program of studies, it states that formulas will be given for any problems involving log scales such as decibels, earthquakes, intensities, and pH. So you'll be given the formula with which to work with, but we still need to go through and develop an understanding of how these scales were formed. So the Richter scale, which is used to measure the magnitude of an earthquake, was named after an American seismologist. The magnitude of an earthquake is the measure of the amount of energy that is released and is determined from the logarithm of the amplitude of the waves that's recorded by the seismograph. This is a logarithmic scale, which means a difference in 1 unit is 10 times the intensity. So what that means is a magnitude of 9 is 10 times greater than a magnitude 8 earthquake. It's 100 times greater than a magnitude of 7. It's 1,000 times larger than a magnitude of 6. A magnitude of 1 on the Richter scale is approximately equivalent to a blast of 14 kilograms of TNT. It's 10 times as intense as the 0 point of reference. An earthquake that had a magnitude of 2 would be 100 times as intense as the 0 point of reference. Anytime an earthquake has a magnitude of over 6, it's considered to be dangerous. It's considered to be causing damage. The largest recorded earthquake was 9.4, and that was in Chile in 1960. The largest one we've had on record in North America was in 1964, was in Alaska, and it was 8.4. So if we look at the scale, and then we look at these questions, an earthquake of magnitude 8 would be how many times as intense as one that is magnitude 7? So each level is a power of 10. So it would be 10 times greater. Good. Okay. An earthquake of magnitude 7 is how many times greater than an earthquake of magnitude 3?
40?
Not 40. It's
10 times 10 times 10.
So it's 10 to the power of 4, which would be
10,000.
yes, or put it on paper. Okay. What would it be?
10,000.
Yes. Okay. An earthquake of magnitude 4 is how many times as intense as an earthquake of magnitude 6? Power of negative 2. Good. So it'd be 1/100th times as intense. An earthquake of magnitude 4.8 is how many times as intense as an earthquake of magnitude 6.8? That would still be the same as before, 1/100th, because it's 2 levels below. The earthquake in 1960 in Chile, which had a magnitude of what? 9.5. Was how many times as intense as the 1976 earthquake in Italy? So what was the earthquake in Italy?
6.5.
Okay. So how many times as intense is that Chilean one? 1,000, because there's 3 levels. And how many times as intense is the 1983 one in Colombia? So what was the one in Colombia? 5.5. So this Chilean earthquake is how many times as intense as the Colombian one? 10,000. 10 to the power of 4. And the earthquake in Turkey, which had a magnitude of
6.9.
is how many times as intense as the earthquake in Japan in 1933, which was what?
8.9.
Okay, so how many times as intense is the Turkey one compared to the Japan one?
100.
100th, because again, it's 10 to the negative 2. Okay? Now, all of these were nice and easy because they were exactly 2 levels, or 3 levels above, below, or 4 levels. But what would happen if we wanted to compare the intensity of the earthquake in Chile with a magnitude of 9.5, and then the one that Chile had several years, 45 years later, that had a magnitude of 7.8. So to compare the intensities of the magnitude 1 and magnitude 2, consider the following. The magnitude of an earthquake is given by the formula m equals log I over I0, where I is the earthquake's intensity and I of 0 is the reference intensity. So I have magnitude of the first earthquake is the first intensity divided by the reference, and M2 is the second intensity divided by the reference. So first of all, it says show that M1 minus M2 is equal to the log of I1 over I2. So what is M1?
Log I1 over I, like that.
Okay. And what is M2?
Log I2 over.
Are the bases the same in the 2 logs?
Mm-hmm.
Yes. So could I use any of my log laws?
You can divide the.
Okay. And I'm going to actually show it as a division symbol rather than using the division bar. So how do I divide fractions? Invert and multiply. So this becomes I1 over I0 times I0 over I2. And when I multiply them together, the I0s will cancel, and there I've got my log I1 over I2. The other way that you could do this is at this point you could split all of these up. So you could split this as being I1 minus I0 minus and then brackets. And all that would end up happening is the I0s would cancel out again, and then I would get I1 minus I2, which then I could use the quotient law. So it's another way that you could solve it. Okay? So if M1 minus M2 equals this, show that this equals 10 to the power of M1 minus M2. Well, if I have that M1 minus M2 equals this, what's the base of this log? 10. So I can write this as a power. 10 to this power equals the argument. This is what would be provided to you. So you wouldn't be expected to derive this. This would be given to you. So all that means, really, is that if I wanted to find the difference in the intensities, I would take the one magnitude minus the other magnitude, and it would be to the power of 10. So if we go to that question, the 19 Chile earthquake, which was 9.5, and the 2005 earthquake, which was 7.8, this would be 10 to the power of 9.5 minus 7.8. And what would that equal? To the nearest whole number. So 50 times as intense. Does that mean that the 1960 earthquake would have caused more damage than the 2005? So what would happen in Chile in the last 45 years? From 1960 to 2005?
We probably have more people in buildings in 2005. There's probably more damage in 2005.
The more buildings you have, the more damage you're going to have, right? Especially depending on the quality of the buildings built. Like some of the buildings would be built to resist an earthquake if the region is thought to be earthquake sensitive. Hannah, you have, like in the Philippines, a lot of your buildings, would they be considered earthquake sensitive, or because of the codes and the tremors that you guys have in those regions, right?
Where in the zone earthquakes are just like in Japan.
Okay.
That's what it's dangerous.
So you try to make the buildings as safe as you can, but ultimately if you have a large earthquake, anything over a 6 being considered a large earthquake, if buildings start to collapse, you're probably going to have more damage. Okay? A major earthquake of magnitude 7.5 is 375 times as intense as a minor earthquake. Find the magnitude of the minor earthquake. So the intensity is the 375. And this becomes 10 to the power of the major minus the minor. The major being 7.5 and the minor we'll call x. So how would I solve for x? How would I pull that exponent down? Put it into a logarithm. So log base 10 of 375 would equal 7.5 minus x. So how would I get the x by itself? Actually, let's look at this for a moment. Is my x positive or negative?
Negative.
Negative. So how do I make it positive?
Put it to the other side.
Let's bring it to the other side. And then if I bring it to the other side, what am I going to want to do with this log 375?
Subtract it.
Subtract it. And can I put log base 10 375 in my calculator? Do I need to change a base for it?
No.
No, because it's already a base 10. So then what would I get to the nearest 10?
4.9.
Okay. So we just need to make sure that we're reading the questions carefully so that when we're looking at the intensity, we know where to put the major and the minor. If this had been a fraction, then the smaller earthquake would have come first, because that's how I would have gotten that fraction. It would have to be a negative power. Okay? The decibel scale and the pH scale are the decibel and the pH scales are the other two scales that we're going to look at. They basically are the exact same. We're doing the exact same thing each time. So the Bell schedule is a measurement for loudness of sound. It's originally measured in bells, but the current measurement that we use is a decibel, which is equal to 1/10. So if I look at my scale here in decibels, what I would need to do is convert all of these into bells by dividing by 10. So a whisper, which is I think 30 decibels, would be 3 bells. The Bell schedule is logarithmic, which means a difference in 1 bell or 10 decibels is 10 times the intensity. The threshold of hearing is considered to be 0. A whisper is 1,000 times as intense as the threshold of hearing. And then it's 100 times as intense as a leaf rustling. And that's a whisper. So if we look at the examples, a power saw, which is 120 decibels, so that would be 12 bells, is how many times as a telephone dial tone, which is 80 decibels or 8 bells. So how many times louder is the power saw? How many levels did I move?
4.
Not 40, I moved 4.
Yeah, 4. That's
So 10 to the power of 4, which would be 10,000. Okay. A jet engine is how many times as loud as the threshold of pain? How did you get 100, Evan?
Because you'd go up 2 levels.
Go up 2 levels, 14.5 and 12.5. Okay? And a whisper is how many times as loud as a conversation? And how did you get 1/1000?
Because you'd go like 3 levels down, so it'd be 10 to the negative 3.
10 to the negative 3, good.
So, wouldn't the first one be wrong then? Because aren't you going 3 levels down from 12, or 4 levels down from 12 to 8?
But the power saw is louder. So I'm looking at which, like from the louder to the softer. This one is the softer to the louder, so it becomes negative. So when you're moving down, when you're going from the louder one to the bottom, to the softer one, it's a positive, but when I'm going up, it would be a negative. So to go from the whisper to the conversation, I'm going up, so it'd be considered a negative. Look, read the question again.
Okay, I think.
If you read the
Yeah,
question,
that
then
makes
it becomes, as you're reading it, you can see that it has to be 10,000 times as loud, whereas the whisper has to be 1/1000th times as loud because the conversation is louder. Okay. And again, on the following page, we have this comparison of the intensities where we can subtract the bells, so 10 to the power of the bells. If it's given to me in decibels, then I would just subtract the decibels over 10 or change them into bells beforehand. Okay? So it says, given that decibel equals 10 times log of the intensities, show that the decibel level for the threshold of pain has a sound intensity of 10 to the power of 12.1 times the initial intensity. So if I use this formula, I have 125 decibels equals 10 times log, I over I0. And really what I'm trying to do is I'm trying to solve for I. So I want to isolate this logarithm, so what do I have to do with the 10? Divide by 10, so it's 125 divided by 10.
12.5.
Okay, now what would I do?
Change it into exponential.
Okay, and in an exponential form, what would that be?
10 to the power of 12.5 equals I over I0.
Okay, and I'm trying to get I by itself, so what do I do with the I0?
Times it by 10 to the power of 12.5.
So 10 to the power of 12.5 times the initial intensity equals my final intensity. Okay. How many more times intense is the sound of playing the piano than the sound of a whisper? If playing a piano is 67 decibels and playing the whisper is 22, how would I do that? So what did you do, Evan?
I changed them both to bells,
Okay,
and then I went 10 to the power of 6.7 minus 2.2.
which would be 10 to the power of,
4.5.
okay. And 10 to the power of 4.5 equals,
31,622.7.
okay. Two telephones in a home ring at the same time. Each telephone has a loudness of 80 decibels. Does this mean that the total loudness is 160? Explain why or why not using sounds intensities and the properties of logarithms. So if we look at this, what we did up here, this was kind of my formula for my sound intensity. So I am trying to show that, let's see, if I let the total loudness be X decibels. Or I guess maybe X bells might be better. So I have two phones that are running with an intensity of 10 to the power of 8. And I want to know what that is going to equal, 10 to the power of X. So in order to move this exponent down so that I can solve it, I can't write this in logarithmic form this time. Like I can't take this as an exponent because I've got this product over here. So I take the log of each side. I get log 2 times 10 to the power of 8. Right here I have the product law, so I can split that up into log 2 times log 10 to the power of 8 equals x times log 10. Oops, sorry, there should be a plus, not a times. What can I do with this log 10 to the power of 8? What can I do with that exponent of 8? Bring it in front. Oh, and what is log 10? 1. So this is just x now. Equals log. So So log 2 plus 8 log 10. What's log 10? 1. So this becomes log 2 plus 8. And what does that equal?
8.309.
And this is bells. So how many decibels would that be?
83.
So 2 phones ringing at the same time would not double the intensity. Okay. So 2 groups having a conversation does not double the loudness, but it does make it louder. It's just not twice as loud. So next time your mom says that you guys are twice as loud, you can argue with her and say, mathematically, you're wrong, Mom, because I can prove it. And then when you start talking logs, her eyes will glaze over and you won't have to go any further. Okay, the last logarithmic scale is the pH scale. So the pH scale, when that one is displayed as a horizontal scale. And it's a little bit different because in a pH scale you have acids and you have alkalines. So in your pH scale you've got pure water, which usually is considered at like 0. And then as I go to the right, I increase in alkalinity. As I go left, I increase in acidity. So when we're looking at a pH scale, we have to be very careful because if we're moving one direction, we're talking about acidic. So we can say that a soft drink is more acidic than seawater. But then we can turn around and say that milk of magnesia is more alkaline than lemon juice. Not that we would, but we can say that. Okay? As we move throughout the pH scale, everything is a power of 10. But which one is more acidic, the soft drink or the vinegar? The vinegar. Even though the numbers don't necessarily show it, it's what is more acidic because of the direction that you're moving. When I'm moving on this side, which is more alkaline, the milk of magnesia or the washing soda? Pardon?
The washing soda.
The washing soda. Okay? So then it says, therefore, if vinegar has a pH of 3, it is 10 times as acidic as tomato juice, which has a pH of 4, and 100 times as acidic as normal rain, which has a pH of 5. So it says, complete the following using the approximate pH values that are given on the side. So tomato juice has a pH value of what? What's the pH value of tomato juice?
4.
And what's pure water?
7.
7. So tomato juice is how many times as acidic as with pure water?
$1,000.
1,000. And eggs have a pH level of
8.
and pure water is 7. So eggs are how many times as alkaline as pure water?
10.
10. Okay. Milk of magnesia has a pH of 10.5. And blood has a pH of 7.5. So this time we have 2 blanks to fill in. Milk of magnesia is blank times as blood. So what would my blanks be?
Could you do 1,000 times alcohol?
Are you asking or are you telling me?
I'm telling.
You're telling. That sounded like a very confident tell. Could I also say that milk of magnesia is 1/1000th times as acidic as blood?
Yeah.
Yes. But what would we generally pick?
Probably yes.
Probably the alkaline, because both of those values are on the alkaline side of the scale. Blank is 100 times as acidic as normal rain. So normal rain is 5. So do I move up this way or do I move down?
Up.
Why up?
Because it's becoming more acidic.
Because of the word acidic. Good. So what is 100 times more acidic than normal rain?
Vinegar.
Vinegar. Okay. And eggs that have a pH of 8 are how many times as alkaline as washing soda, which has a pH of 12?
1/10,000.
1/10,000. Good. The fact that you guys rock in science helps too. Okay, so again, we can compare the pH or the acidity and alkalinity of one solution to another by using the formula 10 to the power of the pH of one minus the pH of the other. So pure water, swimming pool water, and seawater have pH levels of 7, 7.5, and 8.4 respectively. How many times as alkaline as seawater, is seawater than pure water? So the question is, seawater is 8.4, pure water is 7. Would this be 10 to the power of 7 minus 8.4 or 8.4 minus 7?
8.4 minus 7.
8.4 minus 7, good. What do you get?
25.
So seawater is 25 times more alkaline than pure water. How many times as alkaline as swimming pool water is seawater? So is it 8.4 minus 7.5 or 7.5 minus 8.4?
7.5 minus 8.4.
Other way around.
8.4 minus. How do you know? Like, I don't understand how you know.
As and is. So 8.4 minus 7.5, which is 0.9. So 10 to the power of 0.9 is
7.9. So it'd be 8.
8 times. So if I put it in here, you can say that swimming pool water is 8 times more alkaline than seawater.
No, wouldn't it be the other way around?
No, swimming pool, or sorry, yes. Seawater is 8 times more alkaline than swimming pool water, sorry. Then we have the formula for pH, which I think you've used before. This negative log of your hydrogen ion concentration. So a patient gave a urine sample which was found to have a pH of 5.7. What was the hydrogen ion concentration? So if I put this into my formula, I get 5.7 equals negative log H. So how would I isolate the H? First of all, what do I do with the negative? How do I get rid of the negative here?
Divide by negative.
Divide by negative. So I get negative 5.7 equals log of my hydrogen ion. How do I get rid of the log? exponential function. So 10 to the power of negative 5.7 equals my hydrogen ion concentration. And we want to use scientific notation. You're right, CJ. See you tomorrow. Oh, you got your hair cut. Okay.
Practically whatever it was.
So, what do I get?
2.0 times 10 to the negative 6.
And that is measured in moles per liter. Okay. Question number 11 says determine the pH of a solution to the nearest tenth if the hydrogen ion concentration is 3.4 times 10 to the negative 4 moles per liter. So pH equals negative log 3.4 times 10 to the negative 4. And I can put it in exactly as I see it. What'd you get, Fabia?
3.4685, so 3.5.
3.5. And then what I could possibly do is I could possibly look at a reference chart and then I could actually determine what possibly the substance is. Because now I know its acidity. So the questions for you, 1, 3, 4, 7, 8, and 10, 11. And that is chapter 4.